Welcome to this topic on water and waste. This is for the Airbus A320 family of models. This is going to be very short. The two sessions are session 1, which is going to be water and air. I generalized it by saying water and air. And session 2 on vacuum. So we're talking about a vacuum system. Session 1 on water and air. Let's go ahead and start with this. Water and waste, obviously on the aircraft we have facilities available for the flight crew and for passengers for lavatories and whatnot. So we need a water system. Obviously water is involved here, as well as air, because we need the pressurization of air that's being supplied from the water tanks to, through the supply system to the end users. And that is why I mentioned about the air part. All right, with water, what we have here is obviously a water tank. We're going to have different tanks. We have a potable water tank, as well as a waste holding tank. So those two tanks exist. The potable water system is obviously for, again, supplying water to the faucets and the lavatories, any other facilities there. Some of the components that are involved with the water system are going to be obviously your water tank, the indicating of quantity of water in that tank, the distribution system, of course your air supply system, which will come, by the way, from the main engines. And there's also some of the insulation or the types of lines that are used in the whole system is insulated, because we're trying to prevent ice from forming if you have water. All right, and then depressurization as well is there. And by the way, the depressurization system is in place in case it gets too cold. You want to have a decrease in some of that pressure that normally would be, at a certain pressure, which, by the way, is between 22 and 25 psi. All right. Your tank itself, the tank, by the way, as far as its location, is a test question. So, but be aware that it just depends on which model variant. For example, the series 501 through 599, you'll have the water tank being in one location, and if you have a different series of Airbus A320, somewhere in the A320 family, that may be located slightly somewhere else. So just keep that in mind. The one I'm talking about right now for a certain series is actually located, so one potential place is going to be in the pressurized area under the floor on the left hand side, which will be behind the rear cargo compartment. That's where that is. And of course you also have the water service panel. That water service panel is there, and that incidentally is located in the left-hand lower fuselage. Okay, in the left-hand lower fuselage. That is a test question. Okay. What you have, of course, you have different valves that are involved with the potable water tank. Obviously, the filling of it. So if you're going to fill it, you have to make sure that the valve is open. I'm talking about the fill drain valve. So that is one of the components involved. And back to when I talk about the service panel, you have, of course, you've got the fill drain control handle so that you can fill the tank with water. You also have a quantity indicator there, and then you have control lights for the different drain valves. You have your couple of drain valves as well as an overflow valve, and of course some limit switches. All right, the tank itself, as far as components that are affixed to it, you have an overflow port, as well as the connection for filling, obviously for filling and draining, and of course the distribution that goes to the end users, and then the connection for air pressurization as well. Okay. And the filling of it, if you happen to, as far as just a generic procedure, You have, if you wanted to fill the tank, the valve has to be open, and it opens when you are turning the control handle at the water service control panel, the water service panel. And what you'll see on there is a normal and fill position. So from normal position, if you're ready to fill it, then when you turn the handle, it's gonna be, you know, in the position of fill. Okay, maximum pressure that's required, and this is again for certain variants. In particular, this would be in the 300 series variant. It's going to be 50 psi as a max pressure that's required to fill the tank. Okay, now there is a way, typically you're going to be having it automatically or have electrical power when you're filling it, but it is possible to fill the water tank when there's no electrical power, just so you're aware of that. The tank itself, like I mentioned, it's under the floor behind the rear cargo compartment. It's obviously designed, you know, the tank itself, just to describe a few characteristics, it is designed obviously to handle the pressure that's necessary for it to move the water to, you know, to distribution. Okay. As far as its secure position, there is a structure where you have clamps, and that keeps it in place. All right. There's really not much else to say about, you know, that your quantity indicating system is a visual style. I mean, there's not much to that. Obviously, you have different switches for the service door to be opened so that you can, you know, do maintenance, etc. And so that's, again, pretty standard stuff. Your distribution of the water, remember what I said, it's going to the lavatories, you know, which, you know, water faucets and other, you know, other things as well. So the water is going to those places. And all of that is, you know, through the hoses that are under the floor. And just keep in mind, like I said before, the hoses are insulated because we want to prevent ice from forming if the temperature drops, you know, to below freezing. Okay. The water faucets themselves have a self-venting mixing valve, and that just enables it to use, obviously, the water heater, because there's a water heater as well to heat the water so that we have hot water. So just know that's part of that. You do have manual shutoff valves that are isolated there, okay, or they're there, and they're just going to separate the water that goes to the water faucet and the toilet from the potable water distribution system. So I was able to, again, create an isolation system of providing or distributing the water to one end user versus another. Okay. All right, and there's different valves. I'm just going to name a few of them. I already mentioned about the manual shutoff valve. Your rinse valve, this is your toilet rinse valve that has, it's electrically done, okay, electrically operated. All right. And of course, then you also have your water waste drain. So you have your drains involved in this whole system. Your drain valves, those are obviously installed in the drain lines. They're just gonna, I mean, obviously you have your valves there to prevent any leakage of cabin air through the drain lines. So you have that. The water itself is being discarded to the outside. So it's, you know, that's the process there. And you have also I mentioned about the drain mast. The drain mast, you have a pressure difference between cabin and drain mast outlet. Between those, that's going to discard the wastewater through the drain mast. Okay, and gravity is going to be part of helping that process happen. Air supply, I mentioned about an air boost. Because what if you don't have, remember the source of air, by the way, being supplied to the water tanks for pressurization to get the distribution going, is actually coming from the main engines. And if for some reason that's not functioning as far as that receiving of that bleed air from main engines, or the APU for that matter, there is an air boost system, and that is going to be supplying that pressurized air to the potable water system to maintain the pressure that's necessary to move that water through. All right. And of course you've got different valves, and your pressure reducing relief valve that's going to reduce the air pressure from a certain pressure to obviously the working pressure. Okay, and as far as any kind of indications that you'll see, you have a push button or push button switch. That's WTR system DEPRE. That stands for water system depressurization, and that's going to be on a panel. And again, that just allows it to decrease some of that pressure to the working pressure. All right. Okay, let me go ahead and go ahead and cover question number 3 on your handout. What is the purpose of the air boost system? Is it to ensure that there's enough air going into the main engines, or is it option B, to ensure there is enough air to pressurize the water tank in the potable water system? Okay, it's part of that. It's B, right? Okay. All right. That's pretty much what I'm going to say for session 1 on water and air. The water, just to recap, is available through a water tank. That's where it's stored until it's ready to be used, and that'll be there to supply water to the galleys and the laboratories. Okay, and you have water faucets, obviously, and the facilities and the laboratories. And the air, of course, we'll talk about air. I'm really referring to the air boost system in case that there's not enough air, bleed air from the main engines, to supply the required pressure for that system, for that water system. Session 2 is on the vacuum. I just called it vacuum because it is a different mechanism when we're talking about facilities. And it's just to get an idea on the components involved. You have obviously you've got there's a waste holding tank assembly. You have transmitters for any sensors, right? All of that is tank mounted, or what I mentioned, the transmitter as well as the liquid level sensor. Those are tank mounted. You also have a vacuum generator and a controller, and you have a check valve, and that's checking for vacuum pressure. You also have the waste drain valve, and of course we're involving the waste service. So earlier I mentioned the water service panel, and now I'm mentioning the waste service panel that is involved here. And then you also have the altitude pressure switch. Okay. As far as the toilet system, you have the cabin installation, and then you also have cabin installation under the floor, as far as where components are located, the pipes and whatnot. And there's diagrams that can help you see that. Best thing to do is, instead of using any instructional, which is what I'm doing now, or providing as information, it is just a guide, because the one you really want to look at is the one where you work. All right, as far as the assembly, and I'm talking about the toilet assembly, you have a flush control unit, obviously a flush valve, and then you also have an anti-siphon valve, a water valve, and the screen, the bowl, obviously, and a supporting frame for all of that, and a manual waste shutoff valve. And there's descriptions for all of those components, but I just wanted to mention to you what, by name, what those are. Okay, and then just to give you an idea of the components that are located under the floor, the vacuum generator is installed there under the floor. That's actually on the right hand of the aircraft, and it's just a unit with some protection, and it has inlets connected to the water separator air outlet, and It's there to be part of that vacuum system. Okay, now the vacuum system controller, that is installed on the right, okay, of lower fuselage. So right side as well, lower fuselage. And some of the components, this is also where you can do a bite test of the controller. This is going to test for faults with different components, such as, you know, what I mentioned earlier, the flush control unit, your liquid level sensor, your transmitter, the altitude pressure switch, the forward attendant panel. These are just some of the things that the bite test is going to test for faults. Okay, last question of this entire topic. And this is from session 3. Where is the vacuum system controller located? Is it right lower fuselage or right upper fuselage? Okay, you're right. It's the first answer. Right lower fuselage. Okay. All right. So you got an idea about what is there about the toilet assembly, that whole process of vacuum, that you have to have a controller for that, and that is located where I mentioned. Of course, you have transducers, you've got the drain valves. These are all part of, you know, the operations with all of that. Okay. I know I'm not going into great detail with this. It's, you know, there's a lot of electrical parts to it. The locations of these obviously is important. I mean, most of them are just under the floor, or if they're not, you know, they're, you know, where I mentioned before. And then you have, again, the water service panel and your waste service panel, and, you know, that's pretty much it. Again, electrical diagrams, better to, you know, look at the ones that you have at your MRO. The fault handling, let's get to bite a little bit and we'll conclude with it. With the way this thing, the fault system works, fault detection system is working, it's constantly going and being able to transmit any fault that it detects. Is going to be submitting that or transmitting that to the ARINC 429 data bus. I know I mentioned that before. That's like the main data bus for receiving those signals, and of course recording it. So that way you're able to get a list of any faults that were recorded or that happened, and can go from there in your troubleshooting. All right, and then also just from a maintenance standpoint, some of the line replaceable units, because not every component is line replaceable. You've got some here in this category, and that would be your toilet assembly, as well as your vacuum system controller, your vacuum generator, the sensor, and the switch. Those are all LRUs. And then you also have shop replaceable units. These shop replaceable units, defects, data, this is all recorded for, you know, for shop maintenance. Okay. And then just there some things that you might see on a bite, and there's some pictures you can show you just to give you an example, not that necessarily this would be what you see, but giving you an example of the way that it's presented on a display. Again, better for you to see a visual of it, but so just an example. One will say lav, obviously for lavatory, but, you know, LAV, and then an X, and then a note. Okay, that's just an example. And of course you have your last leg report, your previous legs report, that have information as well, so that you can do the proper troubleshooting from that point. All right, this concludes our topic on water and waste. Just to give a quick summary, session 1, we talked about water and air. Obviously you have potable water, a potable water system that is providing water that's coming from a water tank where that water is stored, and it has to be pressurized in order to get, you know, as being a supply, in order to get to distribution, it has to be pressurized. That pressurized air is being supplied by the main engine's bleed air. If for some reason that bleed air is not available from those main engines, you do have an air boost system that's in place to provide the necessary pressure that's required for that, for that water system. And then I lastly talked about the vacuum system. This is for the toilet assemblies, etc. All the components involved with that, and making sure all those switches, the drain valves are all functioning correctly. So, and of course here you have a controller, that vacuum controller, and a generator. Okay. All right, that concludes that. If you have any questions at all about this topic, feel free to email us, and I look forward to having you in the other topics.